Hello friends, I am Shahid Komal Kumar from PDPU College. Today I am going to talking about natural gas processing, which is a part of introduction petroleum engineering subject. So my slide cover about natural gas processing mainly four topics: introduction to natural gas, types of raw natural gas well, contaminants in raw natural gas, and description of natural gas power plants. So natural gas is a complex industrial process designed to clean raw natural gas by separating impurities and various non-methane hydrocarbons. Non-methane hydrocarbons are some hydrocarbons which are present in the natural gas, which are ethane, propane, butane, which are removed by depropanizer, deethanizer, which we will describe in the further slides. Also, natural gas processing plants purify raw natural gas by removing common contaminants such as water, carbon dioxide, and hydrogen sulfide. So the natural gas production and delivery process is in three steps: production, transmission, and distribution. Production is the step from where the natural gas is explored, and the distribution last step is the consumer step, where the consumer get the natural gas which is explored by further purification from the plants and compressed, free of hydrogen sulfide. When there is no hydrogen sulfide, it is sweet gas. When there is hydrogen sulfide, it is sour gas. Natural gas with hydrogen sulfide, carbon dioxide, and any other acidic gas is known as acid gas. Raw natural gas come from the methane deposit in pores of coal, and it is also known as coal bed methane, for which today the most of the important source of energy comes from the coal bed methane or coal bed gas. Contaminants in raw natural gas. Now, what are the contaminants present in the raw natural gas? Raw natural gas typically consists of primarily methane, which we discussed before, and with which is the lightest hydrocarbon molecule. Now, other which molecule are also present in the raw natural gas are heavier gas hydrocarbon, which is ethane, propane, normal butane, isobutane, and pentane. All these are collectively referred to as natural gas liquids or NGL when the process is done or as a byproduct we obtain in natural gas power plants. Also, there are liquid hydrocarbons or crude oil, acid gas such as carbon dioxide, hydrogen sulfide, and mercaptans, etc. Other gases are nitrogen and helium, in which we do helium recovery at the end step of the uh, our power plant due to helium is a inert gas. And the more important, water is always present as in form of water vapor or sometimes as in form of liquid water. And mercury is also present in very little amount, which we also describe how it will get evacuated or removed from. This is the raw natural gases pipeline to a gas processing plant, where the initial purification is usually removal of acid gases. Now acid gases, the first removal is hydrogen sulfide. As the hydrogen sulfide is a acid gas, we remove it by sulfur. So sulfur can be removed from the Claus process, contact process, or wet sulfuric acid process are the most used technology for recovering sulfuric acid. Now, the residual gas from the Claus process is commonly called as tail gas, and that gas is then processed in a tail gas treating unit, which is one of the uh, cylinder in the power plant to recover and recycle residual sulfur containing compounds back into the Claus unit. The next step is the gas processing plant is to remove water vapor from the gas using either the regenerable adsorption in liquid TEG, triethylene glycol, or commonly known as glycol dehydration. So we generally remove water from it, which is done in the pressure swing adsorption unit, which is regenerable by adsorption using a solid adsorbent. Now, the another important contaminant which we remove from the raw natural gas is mercury. Mercury is removed by the adsorption process, such as activated carbon or regenerable molecular sieves. Sieves are present. Also, we remove nitrogen by three processes: cryogenic process, absorption, or adsorption. In cryogenic process, using low temperature distillation, the process can be modified to also recover helium. In absorption process, using lean oil or special solvent as the absorbent. And in adsorption, using activated carbon or molecules used as the adsorbent. This process may be limited and applicable to some uh, type of raw natural gas in which loss of butane and heavier hydrocarbon occurs. So the next step is to recover the natural gas liquids. So we have removed mercury, helium, nitrogen, uh, water, sulfide. So the last step remaining is to remove the natural gas liquids, which are ethane, methane, ethane, propane, butane, and etc. So the natural gas liquid was done in three distillation tower: deethanizer, depropanizer, and debutanizer. In deethanizer, ethane is overheated and removed, and the butane and propane are fed down in the depropanization. In depropanization, the propane is removed and bottom are fed to debutanizer. In debutanizer, normal butane and isobutane are removed and C5 plus mixture are uh, stored to the next cylinders. The recovered stream of propane, butane, and C5 plus may be sweetened in Marox process unit to convert undesirable mercaptans into disulfides and along with recovered ethane, and are the final NGL products, NGL byproducts. So they are the final byproducts. Currently, the most cryogenic plants do not include the fractionation for economic reasons, and the NGL stream is instead transported as a mixed product to the standalone fractional complexes located near refineries or chemical plants, which use as feedstock. In case laying pipeline is not possible for geographical reason or distance between source and consumer exit 3,000 km or more distances, the natural gas will be transported. Then ship are used to transport LNG in its gaseous state. The residue from the NGL recovery section is the final and purified sales gas is pipeline to the end user markets. Now, helium recovery is described if the gas has significant helium content. The helium may be recovered by the fractional distillation, and the natural gas may contain such as 7% of helium, and it is commercial source of noble gas. So helium is a very important material and it should be recovered. So in Oklahoma and Kansas field, there is helium recovery concentrations of 0.3 to 1.9%. This is the block diagram. Thank you for the watching my video. You can share your views and any feedback for the video.